Welcome to Human Rights Uncovered, a podcast from the Geneva Academy of International Humanitarian Law and Human Rights, a joint centre of the University of Geneva and the Geneva Graduate Institute.
Hello and welcome to the first episode of Human Rights Uncovered. In this podcast, we explore the major human rights questions shaping our world with experts and practitioners working at the heart of these issues. Our goal is to advance understanding and stimulate discussion on subjects that are legally, politically, or ethically significant and often uncovered. Today, we are opening a mini-series on neurotechnologies in human rights. These technologies that interact directly with the human brain and raise important questions about our fundamental rights. To introduce the topic, I would like to start with a cultural reference our listeners may recognize. In the TV series Severance, employees undergo a brain procedure and get a chip implemented in the brain by the company that separates their personal memories from their work memories. While this is fiction, it raises a genuine question: what happens when technology gains access to a brain? To help us unpack this, I'm very pleased to be joined by two experts. First, we have Dr. Jonathan Andrew, former research fellow at the Geneva Academy of International Humanitarian Law and Human Rights, and a lawyer with over 25 years of experience working on technology, health, and international law. Secondly, I'm very pleased to welcome Dr. Herrera Ferra, neuroethicist and the founder and former president of the Mexican Association of Neuroethics, with an extensive experience in bioethics, neuroethics, and behavioral therapy. Thank you both very much for being with us today. I'm Clémence, your host, and this is Human Rights Uncovered. Jonathan, before we get into the human rights questions, I think it's important to make sure everyone is on the same page. For our listeners who are not familiar with the term, could you please give us a simple definition of neurotechnologies?
So neurotechnologies, these are devices, processes, systems that have been developed to monitor, modulate, access aspects of the human nervous system. And increasingly, they encompass quite a broad array of different types of technologies.
Before we move into concrete medical applications with Karen, I would like to pause for a moment on why this topic matters beyond experts and laboratories. Like, why should people who may have never heard of neurotechnologies before and who don't see themselves as patients or scientists care about this topic now?
We're increasingly seeing neurotechnologies being developed in the consumer sphere. We've, for many years now, seen neurotechnologies in clinical settings, for example, for deep brain stimulation to help alleviate the symptoms of those people suffering from Alzheimer's disease, also people with Parkinson's who have some kind of mobility impairment have also been able to benefit from invasive procedures where stimulations applied to the brain, and this allows them to regain some of their mobility that has been impacted by their disease. And we're seeing a lot of interest from many technology companies. The more well-known big tech companies like Meta and Apple, for example, have moved into this sphere and they see a lot of potential. So increasingly, we'll see more of these technologies incorporated into quite everyday uses of technology that we're quite familiar with. So we may also see them, for example, some sort of use in our interaction with smartphones and with other devices on a daily basis.
And from your research, what do you think are the biggest misconceptions people tend to have when they hear about neurotechnologies? For instance, what do we often get wrong or oversimplify in public debates or media coverage?
Reflecting on what we see in science fiction, popular media, there's a lot of focus on the brain implants, brain-computer interfaces. I think it's right that has gotten attention. It's something that people can relate to in terms of, that's what we call, in terms of any kind of capability where there's an insertion into the brain. We call that an invasive procedure. And that's one that people, I think, can picture and visualize. But we're also seeing a lot of other capabilities that are being developed, a lot of scientific experimentation going on in the area of less invasive types of neurotechnology. Meta, for example, have been doing a lot of work in relation to some wristbands that they recently uncovered to the media in a press conference, which shows that the signals that can go to somebody's fingers can actually be decoded. And they can use these devices, these wristbands, to help persons with, for example, limitations in terms of their mobility interact with different devices. So I think it's important to note also that there's a lot of promise. So a lot of the media to date has very much focused on the sort of dystopian side, the side of that really draws on people's fears of how technology will develop. So I think that's another important aspect in terms of how we reflect and discuss neurotechnologies to ensure that we can help shape how they're implemented, how they're used, and how society can benefit from them best.
This makes a perfect transition to talk about the real-world impact of these technologies. Karen, I would like to turn to you now and look at how neurotechnologies are already being used in medical settings and what they mean for patients in very concrete terms. A few weeks ago, the company Neuralink released footage on social media showing a paralyzed patient controlling a robotic arm purely through thought, thanks to these brain-computer interfaces. These images can feel a bit unreal, and they often circulate without much context. How would you describe the role neurotechnologies play in medicine today?
Thank you, Clémence. Well, we have to first remember our relationship, as humans with technology. So we have been able to develop tools from our environment to help and to make kind of our life easier. So when people hear about technology, it might be like implicitly assumed that it's going to be used for good, right? The thing is that there might be a hype on what neurotechnology can do. And without proper regulation, there is, as you said, the Neuralink and all these companies that are trying or promising things that we might not achieve. So I think we should be very realistic regarding the real good that neurotechnologies can do, but also to be aware of risks. So we currently use especially neuromodulation techniques to help specific depression, obsessive-compulsive disorder, bipolar disorder, where it has been like a real advancement is more in neurological disorders such as Parkinson's disease or all these movement disorders, more, let's say, in the peripheral central system instead of the central nervous system. So not so much maybe in the brain, changing behaviors or thoughts or mood, but mainly movement, like, again, Parkinson's disease. So it is it's a reality that is helping. We need so much more research. We need so much more awareness, and we do need to be aware of the ethical implications and the human rights implications of using this technology for mental health.
Are we talking about tools reserved for a few patients or technologies that are already deeply embedded in how certain conditions are treated?
I will say that it will maybe depend on the country, but I think it is still reserved for special patients. Neurotechnology is not the first option for treatment. Neurotechnology is being used for treatment as, like the last option. For evaluation, it's different. As Jonathan was saying, it can access and read and monitor. For that, that's a daily use basis on our technology, just to read, interpret, and doing some evaluation and diagnosis. But for treatment, I will say we are really, many steps back. So it's mainly, you can see like a daily use for evaluation, but not a daily use for intervention.
Karen, building on your experience as a practitioner, could you please share an example of a case where neurotechnologies changed someone's life?
There has been a real improvement, but also it comes with risk or unwanted adverse effects. What it has been reported is mainly how the patient perceives these changes of behaviors or thoughts or emotions. I mean, these changes being because of a technology implanted or are changing their brain. So there has to be awareness of how patients identify themselves. Like, I am doing this, or is the technology making me doing this? Is this a real me, or is this the technology part of me? So we need to be very aware of how personal identity is shaped by the perception of a technology being implanted on the brain. For example, I had a patient who was diagnosed with ADD disorder, and he was medicated with these amphetamines, and then he always assumed that he was very smart, that he could learn pretty fast, and that he was so much better than his peers. When he was 19 years old, he came to me as a patient, and I didn't see ADD, so I took off the medication. He didn't have the disorder, but then his identity was built with this sense that he could learn so fast and so much better than his peers. And then without the medication, he lost his sense of identity because he wasn't that smart anymore, or better than the others. So we need to make sure that we are explaining the patients that any change on his or her performance regarding self-control or how behaviors, thoughts, or emotions are being expressed can be part of the neurotechnology effect and not be interpreted as part of the personal identity.
Thank you, Karen, for this example. And about this, what ethical consideration matter the most when using these technologies in a medical context?
Well, I think that there is a lot of ethical values and human rights principles as well. But I think that informed consent, that means that we need to be really clear about what neurotechnology can do, cannot do, and what we actually don't know, the unknowns. Usually when you go to doctor and you have your informed consent, it will say you might have this. But in neurotechnology, there are so many unknowns, and we are using this neurotechnology even though we know that we don't know a lot of effects. And I think the patient needs to know this. So it has to be a clear information and honest information, and to involve the patient very actively in deciding how to use this technology. So autonomy has to be like the first ethical value that has to be respected. That if the patient wants or doesn't want this intervention, knowing then that there are a lot of unknowns in this process.
Listening to you, Karen, what really comes through is that neurotechnology can be profoundly empowering when it's used carefully and ethically. But what if it's not the case? Jonathan, I would like to turn now to the broader human rights challenges raised by neurotechnologies. So far, we've talked about neurotechnologies mainly through the opportunities they are bringing, restoring movement, communication, autonomy, but many experts warn that these same technologies also pave the way to entirely new ethical and legal questions. What is, according to you, the core dilemma neurotechnologies create today and what human rights are most directly affected?
So I think one of the interesting things with neurotechnologies is the issues really replicate many of the challenges that we've seen with technology development in the last decade or 2 decades. In terms of what we're seeing is that human rights, we've always seen them in terms of being interdependent, indivisible. But what we're seeing in the digital domain is that the scope of some of these rights is really expanding. And we're not necessarily always appreciating what we consider to be digital rights, in the sense that traditionally we've always thought of human rights, civil and political rights, freedom of expression, freedom of thought, freedom of religion. We think in the context of neurotechnologies around these sorts of rights. But then we also see, for example, the right to health. Also, we see other areas like the right to education, where neurotechnologies might be used, for example, to monitor a student's activity and progress in learning. So we see some of these kind of silos being broken down by neurotechnologies. I think that's one important point. I think a second point is the interaction and development of other technologies that parallel neurotechnologies have also given us some insights. I was recently giving a lecture where one of the postdoctoral students talked to me about social media, and it was asking whether social media, what the relationship is with neurotechnologies. And it was quite curious, because if we think about all the things that we share through many social media platforms, we already share huge amounts of information around our very personal thoughts. We reflect a lot on aspects of our lives that are deeply personal. And the companies that run these platforms are already able to infer a lot of insights around our identities, around our preferences, around the things we like and dislike, our political views, our affiliations, our interests. And so I think in some ways, it's ironic, we've learned a lot from that, in terms of some of the dangers and risks that represents, as well as also the benefits in terms of, for example, with social media helping direct people towards others who might share similar interests, so that they can link to them, network, share interests. And for many people, it's really reinforcing their sense of identity. It helps them meet people, maybe they're part of a vulnerable group, a minority, and it's a way that they can reach out and meet those people. So that's the thinking with some of the benefits of these technologies, that they might help people in that way. And of course, the challenge is finding how we can provide a framework to regulate, ensure that this can be done in a productive and positive sense and minimize the risks.
Compared to other types of biological or personal data, neural data, if I may say, seems to be of a different nature. It can reveal emotions, intentions, reaction, memories. These things go to the very core of who we are. What exactly is at stake here, Jonathan, when we say neurotechnologies could be a threat to our mental intimacy?
I think I sit a little bit on the fence here, in the sense that in jurisdictions, regions where we have data protection and privacy regulation, we have frameworks in many countries that allow for distinctions to be drawn between, for example, health data and other types of personal data, that place health data in a special category of data. So there are specific safeguards relating to how that is collected, processed, and retained. So that's to say that if we look back since the early 1970s, in fact, late 1960s, in countries like Sweden and Germany, when increasingly early computer systems were being used in the health domain, there was very clear recognition that something needed to be done in terms of regulating that activity. So it's not entirely new. It stretches over 50 years, half a century. I think what's novel now is the questions around the inferences, the detail, the granularity, the insights, also how this data might be repurposed. So repurposing means taking data that's collected for one purpose and using it for data processing, for activities that are different from those that for example, patient or consumer may have imagined. And this is really where technologies and capabilities such as those brought forth by artificial intelligence really bring to the fore, because we don't really know at the moment, we don't have a crystal ball. We can't necessarily envisage how AI, artificial intelligence, will enable us in the future to better understand what type of activities taking place in people's nervous systems. And so there's something of a gap in terms of being able to explain and gain informed consent or work with other legal bases for that kind of data collection, processing, retention. So I think a key part of what we need to do looking forward is really to think forward and look at different scenarios and work backwards from them and try and determine how our existing legal frameworks function, and also establish where there are gaps and where we might need stronger, newer regulations to regulate neurotechnologies.
Karen, from a neuroethical perspective, what does it mean to protect a person's mental integrity, and what worries you the most when technologies interact directly with brain processes that shape emotions, behavior, or identity?
Okay, well, from my point, or from the discipline that I mainly have my work, which is neuroethics, we are really concerned about the cognitive processes, that is how our brain thinks, our personal identity, how it thinks, how we the conscious of being conscious, how we think, our free will, how we think, our empathy, emotions, thoughts, behavior, and decision making. And as you can see, these concepts are what mainly makes us humans, and like very, let's say, even sacred concepts. So if we alter, even if we just evaluate or read these processes, this will mean an invasion of privacy. And if we alter these processes, then we are talking about integrity. How are we shaping or even redirecting or fracturing this integrity? So respecting mental integrity is as important as respecting physical integrity. So we are not only concerned, as just what Jonathan just said, about data, right? Because if we talk about this data, it might seem that okay, this is not data, right? What is this? So that's what we are trying to understand, the concept of neurodata or neural data, which is all this information about these cognitive processes that I just mentioned, and also about what are we going to do with it, and if AI is going to interpret this information and then give feedback to neurotechnology. So we cannot think about neurotechnology now without considering that AI is going to be part of this loop of neurotechnology, where neurotechnology reads this data and then have this unique interpretation and will give feedback on the neurotechnology on how or where it's going to alter or modulate certain parts of the brain related to these cognitive processes. So, I think part of the human rights that need to be protected is the mental integrity, just as part and equally as important as the physical integrity.
Jonathan, you worked on a fundamental human right long assumed to be untouchable, freedom of thought. What is at stake here? How is this being discussed at the international level?
So I think one of the things that's been interesting in my time working in neurotechnologies is I feel in some ways I've come a full loop. When I started doing my research for my PhD, I was looking into the notion of privacy and why privacy is important. And it was interesting, we see going back over a century, people saying privacy really is the right to be left alone. I think it was William Brandeis who said that. And I think this really gets to the core of neurotechnologies in some ways, being left alone in the sense that we have this inner freedom, that we don't necessarily wish always to express ourselves. We respond to things in our environment, to interactions with one another. And it's part of our autonomy being able to develop that sense of ourselves and ask ourselves questions without necessarily wishing to share that. So I think this is where neurotechnologies is really important to understand that there is this risk of of this violation in terms of an interference in our right to privacy, but also in terms of in relation to freedom of expression, freedom of thought. These are all overlap. And I think one of the things that has come really to the fore with my research and with my interactions is that we need to look at these questions from an interdisciplinary perspective. I've found that when I look at regulation as a lawyer, frameworks, there's a definite need to work with ethicists, to work with scientists, clinicians, neuroengineers, also work with the people running these enterprises, these businesses developing the capabilities, to learn from different perspectives. And I don't feel that any one area really has all the answers. The more we talk, the more we realize that sometimes our thinking has been quite siloed, quite funneled in a certain direction, informed by our own perspectives, our own education, our own learning. And that's kind of an irony for something like neurotechnologies, is really sort of also understanding the limitations of our individual views and the perspectives, because we really need to look holistically and engage in much more discussion to find the answers.
As we've seen, neurotechnologies promise extraordinary progress, restoring movement, communication, and autonomy for people who had lost them, transforming the lives of millions of patients. But the ability to access and interact directly with the brain also raises entirely new ethical and legal questions, because when technology gets inside our brain, emotions, or memories, it touches something deeply personal. The challenge here is not whether to innovate, but how. How do we encourage life-changing medical advances while preventing misuse, exploitation, or new forms of inequality? In the next episode, we will explore the most sensitive scenarios and the global efforts, including neuro rights, to regulate neurotechnologies and to protect the human mind. Jonathan, Karen, thank you both so much for sharing your expertise and helping us unpack a topic that can feel complex but affects us all. And to our listeners, thank you for joining us on Human Rights Uncovered. We hope to see you in our next episode.
You've been listening to Human Rights Uncovered, a podcast from the Geneva Academy of International Humanitarian Law and Human Rights, a joint centre of the University of Geneva and the Geneva Graduate Institute. Find us at geneva-academy.ch and subscribe wherever you get your podcasts.